Welcome to this explainer. Today, we're diving straight into a totally critical piece of maritime engineering, the Tanktech X-Mist system. Look, if you're operating a vessel, you already know that a fire in a Category A machinery space is literally one of the most catastrophic emergencies a crew can face, right? You need a line of defense that is immediate, absolutely precise, and overwhelmingly effective. Well, that is exactly what this system is designed to provide. In this explainer, we're going to decode exactly how it works, how it's built, and how to troubleshoot and keep it ready for the moment you hope never actually comes. Okay, let's dive into this. First up, we need to understand the underlying physics here, because this system doesn't just, drown a fire with a giant hose. It's way smarter than that. The X-Mist system actually relies on dividing water into incredibly fine droplets. There's this really clever trifold attack at play. By creating this extremely fine mist, the system exponentially increases the total surface area of the water. This maximizes the evaporation rate, which rapidly cools the area, instantly displaces the oxygen with water vapor, and essentially blocks or attenuates the radiant heat so the fire just can't spread. It's a highly calculated, precise physical reaction. So here's our roadmap for today. First, we'll meet the X-Mist system. 2, we'll go over specifications and main components. 3, automatic and manual operation. 4, installation and piping guidelines. And 5, inspection and testing procedures. All right, Section 1, meet the X-Mist system, certifications and core specs. Let's see what we're working with here. When we're talking about protecting engine rooms, reliability isn't just a corporate buzzword, right? It's a strict legal and operational mandate. This system holds a type approval certificate from Det Norske Veritas, officially approving the X-Mist as a fixed water-based local application system specifically for Category A machinery spaces. What that means for us is that this system has been rigorously tested to withstand the incredibly intense, high-vibration, high-heat environments typical of modern marine vessels, complying strictly with SOLAS regulations. Moving right along to Section 2. Specifications and main components. The anatomy of X-Mist. Scaling this system for different risks is a precise science. Not every single part of the engine room requires the exact same level of suppression. For instance, the main engine setup is going to demand 13 high-level nozzles pushing 182 liters per minute through a 50 nominal diameter pipe. But compare that to the heavy fuel oil purifiers, which really only need 2 low-level nozzles running at 30 liters per minute. The crucial takeaway here is that to supply all of these zones simultaneously with a 20-minute safety buffer built in, the whole system requires a maximum freshwater capacity of roughly 5 cubic meters. Now, pushing that much water at high pressure requires some serious hardware. The scope of supply for the X-Mist system includes a heavy-duty, multi-stage inline pump, and that's driven by a super robust 6.3 kilowatt, 440-volt motor. It also features a comprehensive main control panel that serves as the absolute brain of the operation, motor operating valves to physically direct the flow, and of course, the highly specialized spray nozzles themselves. Zooming in on those nozzles for a second, these things are meticulously machined from SUS 316 stainless steel to completely prevent corrosion, and they are fitted with these LDPE protective caps at the top. Basically, they shield the delicate nozzle heads from ambient dust and stray paint during normal, everyday ship operations. But here is the genius part. You don't need to manually run around and remove them during an emergency. The exact moment high-pressure water hits the nozzle, those caps detach automatically, allowing the mist to deploy instantly.
Okay, Section 3, automatic and manual operation, system activation.
Let's talk about the automatic sequence, essentially the system's built-in reflexes. A fire must actually be picked up by 2 completely separate detectors to fully activate the system. If just one detector trips, you get a pre-warning alarm. But if that second detector actuates, the system takes over entirely. It sends out a major alarm, commands the main control panel to start up the pump, and automatically opens the specific section valve for that particular zone. Once activated, a highly vital pressure check occurs right on the pump's discharge side. If it's rated under the design pressure of 7 bar, an abnormal alarm triggers so the operator can jump in and troubleshoot. But if it's over 7 bar, boom, it immediately begins firefighting. Alternatively, an operator totally does not have to wait for the automatic system to kick in. If a crew member actually spots a fire first, they can manually initiate the whole sequence from a local control panel right near the protected area, or directly from the main control panel in the engine control room. Once that manual start button is pushed, the logic basically mirrors the automatic sequence. Alarms sound, the pump starts, The section valve opens, and that exact same critical 7-bar pressure check happens before the mist is discharged. It essentially puts total control into the hands of the crew. Now, the thing bridging the gap between those electronic panels and the physical pipes is the motor operation valve, or MOV. Using the main control panel or the local push-button switch, the operator can electronically command the MOV to open or close the exact valves needed. This provides extreme accuracy and response performance, meaning absolutely no one has to run down into a blinding, smoke-filled room to manually crank a heavy physical valve open. It's a real game changer for safety.
All right, Section 4, Installation and Piping Guidelines, setting it up right.
Water flowing at high pressure creates immense kinetic energy. Because of this, all nozzles must be installed pointing strictly downward. Moreover, the piping must be strongly supported with specialized heavy-duty brackets. The distance between the support bracket and the nozzle actually has to be kept as short as humanly possible. Why? To completely prevent the nozzle from violently detaching or vibrating loose when the 7 to 16 bar pressurized water suddenly slams into the line. The piping network also has some really strict operational rules we need to follow. Right after installation, every single pipe must be blown with compressed air to clear out debris, because honestly, a clogged nozzle is completely useless in a fire. Drain lines are also absolutely mandatory to ensure water doesn't sit and stagnate in the delivery lines over time. On the pump side, a strainer must be installed on the suction line, and the piping has to be physically fixed in a specific way that totally prevents an airlock. And perhaps the most critical rule for the mechanical longevity of the unit, you must completely fill the pump with liquid before starting it. Never, ever run the pump dry. Seriously, don't do it. Which brings us to our final section. Section 5, Inspection and Testing Procedures, Readiness and Troubleshooting. A fire system is ultimately only as reliable as its last inspection, right? The manual outlines a totally clear, non-negotiable maintenance schedule. Daily checks ensure the control panel is clear and completely free of abnormal indications. Monthly, you're literally listening for abnormal noises on the water pump and verifying the pressure, alongside testing the wire connections and lamps. And annually, that's a complete overhaul of the pump unit, the motor, section valves, and filters, plus meticulously checking all nozzles for clogging. Skipping even one of these intervals totally compromises the entire system. So you might be wondering, how do you actually test a system that pumps 5 cubic meters of water without, accidentally flooding your own engine room? Well, you follow this exact 6-step operation test procedure. First, ensure all section valves are strictly in the closed position and the main water supply valve is open. Then, you open the pump drain ball valve. From the main control panel, you turn the select switch to manual and push start. At that point, you can safely check the pump's running condition and verify the pressure on the gauge while the test water just drains out harmlessly. Finally, push stop and drain out any remaining water from the pump unit. It's simple, but absolutely critical. Now to test the automatic logic. Again, without flooding the space, you perform an automatic release test. This time, you completely close the water supply globe valve and physically disconnect the motor power cable. You open the air ball valve, allowing compressed air into the system. Then, you simulate a fire by actually actuating 2 detectors in the relevant area. You verify that the main control panel and monitor panels alarm correctly, and you visually check that air is releasing from the appropriate nozzles. This confirms the path is perfectly clear and the section valves opened automatically, just like they're supposed to. But wait, after any test or real-world use, you can't just turn the system off and walk away. As a critical troubleshooting and reset step, you must drain out all remaining water and blow the entire piping system through with compressed air at a pressure of 7 to 8 bar. This guarantees free passage of air from the nozzles, ensuring that literally zero moisture or debris is left behind to cause corrosion or clogs before the next emergency. And that brings us to the end of our explainer. Understanding the X-Mist's anatomy, flowcharts, and testing protocols begs the ultimate question, doesn't it? Is your vessel truly prepared? Do you have the discipline to follow the monthly and yearly schedules? And is your crew genuinely trained to execute both automatic testing and manual operation flawlessly in the heat of the moment? The engineering here is incredibly sound, for sure, but its success relies entirely on your readiness. Thank you so much for joining me, and stay safe out there on the